Alright, trigonometry students, welcome to 6.3 homework. Finally, we're going to go through these questions here. So if you had questions on this homework assignment or any of one of these problems, let's go for it. So first things first is 6.3. Number 1. Okay, the problem is sine theta is equal to 3 square root of 3, and it looks like we're in degrees. That's cool. Okay, with that, let's jam. So first things first is take a look at the unit circle. That's what we want to do. So notice that let me see if I can get a pin here. There it is. Okay. Whew. There it is. Notice that the trig function is already solved for. Right, so that's what we need. We need the trig function solved for. We're good. Now we're going to have to figure out what is sine square root of 3 over 2 along the unit circle itself. And so if we think about it here, let's see. I think let's see quadrant 1 and also quadrant 2 because it's positive. That's awesome. And I think about right here. Notice, remember sine function? I always think of it this way here. Sine function, if it's small, it's going to be 1/2. So it's just climbing up the y-axis. So 1/2 is at 30 degrees. And then at 45 degrees is root 2 over 2. And then at 60 degrees is root 3 over 2. And then it gets to 1. Then it falls back down. So in this case here, I'm going to make my right triangle. Okay, that one is going to be theta hat, or the reference angle, would be just be 60 degrees. Perfect. Okay, let's go on to quadrant 2. Make our right triangle here. So now reference angle is still 60 degrees. So the angle itself, it's 60 degrees away from. Let me catch up here. So reference angle is still 60 degrees. That's the way we think about it. In quadrant, don't need to write this one down here, but in quadrant 1, the formula is the regular angle is equal to the reference angle. So that's cool. So I got 2 theta is equal to 60 degrees. And then don't forget that 360k, right? We're going to use the k values here. Just a little easier to do. All right. In quadrant 2, the formula is, we're almost at 180, not quite. So in quadrant 2, the formula is 180 degrees minus your reference angle, or theta hat. So let's go with it here. 180 degrees minus 60 degrees gives us 120 degrees. Okay, so I got that. That's going to be my second one. So I got 2 theta is equal to 120 degrees plus 360k. So we're going to work with that right there. Jump to this one here. So let's jump. I'm going to rewrite it real quickly here. So that's the first answer we got. That's quadrant 1 answer right there. The second one was this one here. And so notice we have a 2 theta on our hands. So all we're going to do, we're going to divide by 2 everywhere. So the angles that I'm looking for are 30 degrees plus 180k each time. Divide that by 2 as well, and it's going to be 60 plus 180k each time. So now the question is, what k's do I use? So originally, remember the problem is 2 theta. So I'm going to use k is equal to 0. And k is equal to 1, or we say I'm going to use 2 iterations. I'm going to use 2 iterations of k. Let me write this out here just so we have it. Since we have 2 theta, we will use k is equal to 0, and also k is equal to 1. So there's 2. That's if the theta was by itself, we would just use k is equal to 0, but since we have 2 theta, we have that one. So if we had 3 theta, we would use k is equal to 0, 1, and 2. So it's always kind of 1 less than the theta that you're getting. Alright, with that said, so if k is equal to 0 for the first one, this is easy. Almost like don't even write it down here. Obviously it's going to be theta is equal to 30 because the 180 goes away completely. K is equal to 1, that's going to be 30 plus 180 because this is going to be 1 right over here. So I'm going to go with 210. Okay, that's for this one here. For our second one here, that goes away completely. So that's just going to be 60 degrees. Perfect. K is equal to 1. It'll be 60 plus 180. So 60 degrees plus 180 degrees would be 240. Perfecto. Okay. There it is. There's the 4 answers that we have. So theta equals, I got 30 degrees, 60 degrees. You don't need to put them in order. You'll find them in the back of the book. They are always in going from least to greatest. You don't need to do that as long as you have all the correct answers and all of them. Okay, that's cool. That is number 1. Let's jump to 6.3. Number 13. Okay, what is the answer here? Sine of 2 theta. Hey, very close to what we did before here. Okay, sine of 2 theta is equal to 1/2. And it says find the answers for all degree values. Okay, again, going back to unit circle. Let me put this little guy down here. Going back to unit circle. And we're going to find where sine, where's the sine value? 1/2. That's what we want to do. Alright, look on your chart if you need to here. I have like this right here. I'm going to have that one right there. So the sine value starts off at 0 as it goes up through the first quadrant. And then we're also going to look at the second quadrant because that's, again, sine is positive in those 2 quadrants. Alright, I got that one. So this little angle, look on your chart here, that'll give me a reference angle of 30 degrees. Perfect. Okay, so 2 theta is going to be, for me, 30 degrees plus 360. Okay, awesome, got one. This guy, reference angle, 30 degrees in quadrant 2. Alright, and in quadrant 2, again, don't need to write all this down. I'm going to write it for completion's sake here. In quadrant 2, I got the real theta, the real angle here is 180 degrees minus your reference angle. Boom. Let's go with it. I'm going to squeeze it into the little bottom right over here. 180 degrees minus 30 and give us 150. Sweet. Okay, so what I have here, I have my 2 theta equal to, my second answer is 150 degrees plus 360. Okay. Alright, just like we did with the last problem. Well, let me go back. Just like we did with the last problem here, I'm going to rewrite this here. So first answer that I came up with, again, you don't need to rewrite it because I need to go to a different slide. Okay, there it is. Okay, all we got to do, divide by 2. That's it. So divide by 2 here, divide by 2 there, divide by 2 there. And I get final answer. Theta is equal to 15 degrees plus 180k. The other one here, divide by 2, divide by 2, divide by 2, and I got theta equals 75 degrees. Okay, then the only thing I got to add into it is, here's my 2 answers, and I got to define what in the world is k. K is an integer. Done. Okay, that was it. So there, all the stuff in blue would be the answer to this. going on. 6.3 number 17 I think is on the list. Yes, 17. Okay. Problem is sine 10 theta equals square root of 3 over 2. Okay, now again, all degree values. Okay, so same thing as 13. We're going to go back to unit circle again. Alright, what am I looking for? I'm looking for when is sine root 3 over 2. In fact, that's actually very similar to problem number 1. So sine is positive in quadrants 1 and 2. So I can put that in already here. That little guy along the unit circle, I'm looking for when the y value is root 3 over 2. Okay, the reference angle is 60 degrees. Perfecto. That's quadrant 1. Sine is positive also in quadrant 2. So I make my little triangle there. My reference angle is going to be exactly the same. So my angle measurement is going to be 180 degrees in quadrant 2 minus the reference angle. And I got myself 180 minus 60 is equal to 120. Okay. I think we are good there. Now we have that 10 theta to deal with here. Let's see if I can finish it off here in one single slide. Let's do this here. So 10 theta is equal to the 60 degrees. That's this one right here. That's the angle measurement from quadrant 1 plus 360k. Boom. Okay, then all I got to do, just like I did for number 13, I just divide everything through by 10 to get me finally to theta. So how about 6 degrees plus, and 360 divided by 10, how about 36k? Final answer, done. Okay, this one here, that's going to be 10 theta is equal to 120 degrees plus 360k. Divide by 10, divide by 10, divide by 10. Let's go with that. Theta would be, at this time it's going to be 12 degrees. Okay, 12 degrees plus 36k. And at the back of the book, they don't even say this anymore, but k would be an integer. They don't even talk about it anymore in the back of the book here. So those are the two answers that they look at in the back of the book. Okay, on to the next one. Alright, 6.3, number 21 is what we have next. And let me write the problem here. It is cosine 3x is equal to 1/2. Alright, just checking something here. Unit circle, obviously, again here. So now we're looking for, it's positive, so you know it happens in quadrant 1 for sure, but we're looking for a coordinate along our unit circle that has an x-axis, or x-coordinate of 1/2. Alright, that guy's going to be at 60 degrees. Alright, the other one, or the other quadrant in which cosine would be positive, would be in quadrant 4 this time. So a little different than sine. Cosine is positive in quadrants 1 and 4. Alright, so we've got to figure out that angle right there. So in quadrant 4, the reference angle is still 60 degrees. So I'll put Q4, theta is equal to 360 minus your reference angle. Okay, so write it over here. So this will be 360 minus 60 degrees, and I got an answer of 300. Cool, cool. Okay. Back to quadrant 1. Okay, so for the quadrant 1 value here, this is going to be 3x now equals, that's going to be the 60 degrees plus 360k. Okay, then this one, just want to make sure, yeah, this one says find from 0 to 360, so we're going to divide by 3. So we're going to divide by 3 here and divide by 3 there. And we get ourselves x equals 20 plus 120. Okay, so notice originally we had a 3k over here, or 3x over here. So we're going to have to do 3 iterations of k. Alright, so when we do this here, so it's going to be for k is equal to 0, that'd be 1 revolution, 2 revolution, and 3 revolutions. So it's always 1 less than the angle value that we have here. Alright, if we do that, you guys can do that in a calculator, you guys can do that in your head real quickly here. So if I just plug in a 0 into k value over here, that would be 20, obviously. If I just keep on adding 120 to 20, that'd be 140. And then multiply this by 2, that would be 240. 240 plus 20 more makes 260. So there's my answers there. Let's go to the very bottom one, this one here now. This would be 3x is equal to 300 degrees plus 360k. Again, divide by 3, and we're going to make 3 iterations for k. So I have, let's see, 100 plus 120 again. Okay. Okay, iterations again are k is equal to 0, 1, and 2. So plug it in. 100 would go first. That's with k's being equal to 0. That chops off. With k being 1, it's 120 plus 100. So 220. And let's see, and 2 times 120 is 240 plus 100 more makes 340. So done. I got all my answers. There are 6 of them. And notice all of them are below 360. 340 is the highest one. So I have 1 full revolution. I found 6 different answers to make that true. Okay, perfecto. Let's go jam. Oh, hold on, sorry, I clicked on the wrong one here. Let's jam to this one. .3. Number 25 is what we got here. That's 25, then 41. A little ways to go, that's fine. Alright, problem is sine of 2x cosine x plus cosine 2x sine x is equal to 1/2. Ooh, okay. Starts off pretty complicated. But if you think about it here, look at your sum and difference formulas. Sum and difference formulas for sine and cosine. Let me write down so we are in radian measurements, and we're going to go 1 revolution, looks like right here. Okay, so this would probably be a long one because first of all it deals with radian measurements first. We have a sum formula over here as well. So alright, let's go for it here. Put your thinky caps on, let's jam. So if you looked at your sum and difference formulas, you found out that this is a sum formula for sine. And the sum formula just means sine of A cosine B plus cosine of A plus B would just give us this right here. So let's see if this makes sense. This would just be sine of A plus B. Alright, so take a look in your textbook here, see if you can see it. So that whole thing right there, sum formula for sine, is just the addition of the 2 angles together. Still equal to 1/2 though. So then 2x plus another x makes 3x. And I got myself a 1/2. So simplified that out completely. That's cool. Okay, again, back to unit circle. And I'm looking for, in quadrant 1, because again, sine is positive, I'm looking for that one. I'm also looking at quadrant 2, because sine is positive in quadrants 1 and 2. Alright, and that little guy, I'm looking for a radian measurement that has the y value of 1/2. And that guy's going to be pi over 6. Dun, da, da, da. Okay, that's the equivalent of 30 degrees. Alright, but we're going to be dealing with radians here. Okay, the other side is over here. Look at your table values here. Where do you see a y value of 1/2 on, or in quadrant 2? It's going to be at 5 pi over 6. Okay, there's our two angle measurements here. Let's jam. So that means that 3x is equal to pi over 6 plus 2 pi k. Alright, done. Except got to divide by 3. So dividing by 3 here, let's see, divide by 3 here, that'll be a fun one. Divide by 3 there. So let's do this little middle one right here. This is going to be pi over 6 divided by 3 would be written a different way. It would be written like this: pi over 6 divided by 3, which we can change that into a multiplication problem. So how about pi over 6 multiplied by 1/3, and gets us pi over 18. Done. Okay, so how this first answer is x is equal to pi over 18 plus 2 pi k. Okay, or just 2/3 pi k. One other way. Either one works. Okay, so can you guys do the 5 pi over 6? Let's do that one. And notice you should see a little pattern that's forming with the radian measurements as well. So this guy, next page, let's go. I have 3x is equal to 5 pi over 6 plus 2 pi k over. Okay, good. Go back just a little bit here on this one. Okay, divide by 3. Yep, divide by 3, divide by 3, divide by 3. Alright, the middle one right here. So pi over 6 being divided by 3. Technically 3 over 1. This is the other way of thinking about it here. We think of it as complex fractions. And what we do is we keep, change, and flip it over. So flip the 3 over 1 to 1 over 3, multiply together. Notice you get this denominator of 18 again. Okay, so final answer, here it is, x is equal to 5 over 8, 5 pi over 18 plus. So it doesn't really matter if the pi goes on top with the 2 or as a multiplier to the fraction. What we have to do is figure out how many iterations we need. So notice we have a 3 on our hands. It's a 3x. So for this one we need iterations of 0, 1, and 2. So we need 3 iterations of k. Okay, here's the next slide, and where there's going to be lots of fractions here. So let me rewrite my answers real quickly here. This is pi over 18 plus 2/3 pi k. The other one is pi over 15, or 5 pi over, 18. Cool. Okay. With that said, let's go with it here. So iterations have to be 0, 1, and 2. For each of those here, let's go. Let's begin. K is equal to 0. Easy answer. Done. This is going to be pi over 18. For k is equal to 1, let the games begin. Here it is. This is going to be pi over 18 plus 2 pi over 3. And then again, we say that k is equal to 1. We'll plug in the 1 for k. That is really just going to be the same thing, but we really need common denominators here. That's what we really need. So I'm going to multiply this guy by 6 over 6. get common denominators of 18. And yes, you shall still see patterns here if you like. So this should be a 12 pi over 18. And final answer, how about a 13 pi over 18? Okay, next one. K is equal to 2. Plug in that value. This is pi over 18 plus 2 pi over 3. This is now times 2. Okay, 2 over 1, just so we have that multiplication. And then also we need common denominators, right? So that 2 is just the k value coming in. To get common denominators, we're still going to multiply 6 over 6 to get that denominator of 18 over here. So pi over 18. Way in the bottom of the slide here. This is going to be 2 times 2 is 4, times 6 is 24 pi over 18. And voila, final answer here is 25 pi over 18. Oof, okay, that's for the first answer. So I'm just going to box them in as final answers each one because it gets a little too messy on the screen here. So let's go to this one. Let's go k is equal to 0. Easy one. That is just 5 pi over 18. I had to save space because I'm going to need it here. I'm going to do k is equal to 1 over here on this side. So x is equal to 5 pi over 18. And some of this you can do in your head. That's cool. I'm just going to rewrite all the steps here. So 2/3 pi times k. Alright, we also need common denominators like we had before, so I'm going to multiply this guy by 6 over 6 to get that 18 on the bottom already here. So how about we got ourselves 5 pi over 18 plus, hey, look at that, it's the same thing that we had on that side, 12 pi over 18, because we're just doing the same iteration for k. But final answer here, how about a 17 pi over 18? Hey, that's almost at 180 degrees, right? 17 pi over 18. Whew, last one, here we go. K is equal to 2. Just like we did on the previous one here, let's plug it in. 5 pi over 18 plus 2 pi over 3 times 2. Technically 2 over 1, and then I need my common denominator again, so how about 6 over 6? And finally here it is. How about lots of writing here, so 5 pi over 18 plus, hey, you know what's going to happen here? I bet you it's going to be 24 pi over 18. Boom, and I got myself my 29 pi over 18 as we add the numerators together. Okay, box this up as well, so how about that one, and that one. And I got all 6 answers, and I am happy now. Woohoo! Cool, cool. Okay. Next on the list, 41. 41. Problem is cosine theta minus sine theta is equal to 1. Alright. Let's see. So let me write down, this is the degree value here. So we're going from 0 to 360. That's cool. Okay. It does say when necessary round to the nearest tenth of a degree. Okay, so that means that just kind of indicates maybe we might have to use a calculator. Good. So let's leave that sort of thinking through this process as we do it. This problem takes about 3 slides to do, so let's jam with it. So first things first, notice that cosine and sine are linear forms. It's not squared anywhere. And we have two of them. So that's our problem. Because we have two of them, and they're both linear, I won't be able to solve this. So the little trick here is to solve for one of them. So I'm going to add sine to both sides. I'm going to solve for cosine. So I'm going to have cosine theta is equal to 1 plus sine theta. Okay. So that's the first trick. And we are going to square both sides, because that gets us into a square of a trig function. And then we can use Pythagorean Theorem to change them around. So on the left side, how about cosine squared theta is it right now? This one, if you know it already, go for it. If you don't, you're going to FOIL all this out. So how about 1 times 1 is 1. 1 times sine is sine. Another sine times 1 is another sine. So how about 2? Got 2 sine theta on our hands. Alright, and the last one right over here, that's going to be sine squared theta. Okay, so now, once that is done, now the question is, which linear form do we still have? We have sine theta as a linear form, right? There's no squares here, right? So we want to make everything in terms of sine. This one's great, except this one still needs to be changed. So we're going to change this guy into the Pythagorean Theorem identity. There it is. So cosine squared becomes 1 minus sine squared. Awesome. So now notice that everything is in terms of sine only. Sine or sine squared. Perfecto. Okay, but now I have another problem. Now I have sine squared terms, and then also have sine linear terms. So in this case, we're looking at factoring or quadratic formula. That's what we're looking at here. So if we're going to be factoring or quadratic formula, I might as well set one side equal as 0. So I'm going to add here, I'm going to add here. Okay, so the left hand side all becomes 0 because everything cancels. That's what I needed there. This becomes, the ones cancel as well, so this just becomes that plus 2 of those. Okay, that's cool by me. Alright, running out of room again, so let me rewrite this on the next slide. So we just sort of keep on going. So it was this, this. Alright, that's what we had from the previous slide. And I usually don't like the 0 on the left hand side, so let me just do this real quickly here. Let me just rewrite this one and put them in order. We like decreasing powers, and we like the 0 on the right hand side. So can you factor, or do we need to use quadratic formula? We can factor. That's easy enough. We're going to factor out a 2 since both of them are in there, and then we're going to factor one of the sines. Sine theta gets to go out. Leftovers would be sine for the first term to give us 2 sine squared theta, and this one, hey, the whole thing came out, so that means just 1 is left over here. Set equal to 0, we can split them off now, 2 different pieces. Let's go with it here. So that one's equal to 0, and the other product is equal to 0. Okay, let's solve each of these now. Divide by 2, divide by 2, and so I have sine theta equal to 0. Done. On the flip side, we're going to subtract 1 from both sides. Now I'm looking for sine theta is equal to -1. Okay, looking at our unit circle. Back to unit circle, I need a y value of 0. When is the y value 0 along the unit circle? Right there. And you can draw your unit circle if you like, or you can just post the points there. This is going to be 0 degrees and 180 degrees. That is easy enough. Alright, when is, again unit circle, when is the sine value -1? Or when is the y value -1? It's going to be right down here. Only one place that happens for sine, which is at 270. Okay, here's a little issue. Remember what we did. What was the trick that we used for this problem? We squared both sides. We squared both sides, therefore we are going to have to, in fact, if you square both sides of an equation, you always have to check your solutions. So let's go with it. We're going to check each one of them. We're going to plug each one of them back into the original problem and see if they work. If they do, that's great. So plugging in the 0 degrees, so cosine of 0 degrees minus sine of 0 degrees. Question is, does that give us a 1? Cosine of 0 degrees is 1, sine of 0 degrees is 0, and that is going to prove true. Perfecto. We'll put a little check mark for now. Cosine is 180, theta is equal to 180 degrees, so cosine 180 degrees minus sine of 180 degrees is equal to 1 question mark. We don't know, we're going to find out. So cosine of 180 degrees is -1. And that is not going to happen. Okay, so we're going to write this over, and what we're going to do is we're going to put a slash through the equal sign. That does not work. That is not working at all. And last one, 270 was the last one that we're going to use here. So checking this one here, so cosine 270 minus sine of 270. Question is, does that give us a 1? Let's check it out. So cosine of 270 is 0 minus sine. Sine of 270 is a -1. And actually that checks out. That is a true statement. I got 2 check marks on my hands here. So out of the 3 possible solutions that we got, one of them was extraneous and the other 2 were true. So 0 degrees and 270 degrees. Okay, 6.3, number 49. Let's see what we have here. I think this is probably the longest problem, maybe, of our homework set here. Alright, we have 4 theta on our hands now. Whew, okay. 4 theta is it. Alright, we are going from 0 to 360. Okay, and then again, this little disclosure here. So when necessary, round to nearest 10th of a degree. So we could possibly be using calculators. Okay, so let's take a look at the problem at hand. I have a linear form. Notice the linear form here is sine. And then I also have a cosine squared. That's cool because I can use Pythagorean Theorem. So let's jam with it here. So Pythagorean Theorem just says I can substitute 1 minus sine squared of my angle in for that. So I'll put that in a little clouds because that's what I'm thinking about here. So now let's put it in. So it's going to be 2 times all of this right here. Plus 2 sine of 4 theta equals 1. Okay. I'm going to multiply the 2 in. 2 times 1, 2 times the rest of that. Da, 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 da. Okay, now we have to start moving things around. So what I do see, I see a linear form and I see a quadratic form of what I have as far as my trig functions are concerned. So if whenever I see that, this one, I'm going to set up for factoring, possibly quadratic formula. So let's do this. I'm going to move that little 2 in front. I'm going to move it to the back, so that means my forms are all together. I have a squared form, I have a linear form, and then I have the constant form. So I moved that little 2 right here, moved it to the other side. And then let's get rid of this 1, since now again I still have this squared form, linear form, constant form, kind of like x squared plus something x plus something. So I'm going to rewrite everything over again, but I'm just moving the 1 over. Subtracting 1 from both sides gives me a 1 this time. So subtracted 1 from both sides. Alright, the only thing I don't like still is the negative in front of sine squared. So I'm going to multiply both sides by -1. And 0 times -1 still 0. But this side, all the signs will change on me here. So I got a positive, a negative, and then a negative. Okay. Alright, that's what I'm going to work with now. And I'm running out of room. So let me rewrite this on the next slide. Alright, Alright, and the question we should be asking ourselves is, can I factor this down? Is this factorable? With a 2 in front, -2 in the middle, and a -1 in the back. And you can try to factor, you're going to find out you can't. It is not cool, not possible. Alright, so what we're going to have to do is we're going to have to find the answer to this. In fact, I should say sine. I'm going to put the sine in just a second here. Let me do that now. It's not for theta. It's not solving for the angle. I put this in as a placeholder just for a little bit here. So it's sine for theta. That's what I'm solving for. Alright, but quadratic formula, look it up if you have to. It's going to be opposite of your b value plus or minus square root of b squared. So it's the same value again, b squared minus 4 times a, which is that little guy right there, times c, which is that little guy over there, all over 2 times 2, or 2 times a value. So back over here to the a value. Alright, simplifying that as fast as you can. So 2 on top here, I'm thinking inside there, that's going to be -2 times -2 is a 4, and then all the stuff. -4. I think of this as a negative here, so it's -4 times 2 times -1. And that should be an 8, still divided by 4. Alright, and I have myself, let's see, 2 plus or minus square root of 12 over 4. 12 is made up of 4 times 3, so that means it's going to be 2 root 3 over 4. And then I can reduce this down some more. I can divide each of these pieces by 2, because 2 is a number that goes into all 4 terms. So 1 plus or minus square root of 3 over 2, done. Alright, let me erase this guy now. Oh, so we solved for sine theta. Alright, now we have little conditions. Remember that for sine can't be lower than -1, can't be higher than +1. It's not possible. So let's check each of these answers here. Let's just check to make sure we can actually get a sine value for it. So on your calculator, punch in 1 plus square root of 3, click enter, divide by 2, and see what you get. And you should get approximately 1.366. And that's cool, but we're going to reject it because you can't have a sine value that's greater than 1. Go to the next one here, 1 minus square root of 3 over 2. And punch that into your calculator here. You should get a negative 0.366, and that is cool. That is a possibility, which means is that we can go back to unit circle, we can solve for one of them. So forgetting the plus value, now let's work just with this little minus value here. So let me rewrite this here. So I'm solving for sine 4 theta is equal to 1 minus root 3 over 2. That's what I'm solving for. Alright, 4 theta equals I'm going to put down 21.47. We good? That's the degree value. How did I come up with it? Let's go with it here. So unit circle. We think about, let me do this on the calculator actually. This would be taskbar, there it is. So the question is, how did I come up with that here? So going from here to here. So I have, there it is. First of all, make sure that you go to degree and you are in degree mode. We are not. I'm glad I checked. So click on degree mode. Going back over here, and I'm going to punch in the inverse of sine. Actually, no, sorry, let me do this again real quick. So what's going to be 1 minus the square root of 3. Click enter. We're going to divide that by 2. There's our negative 1.366 from the previous slide. And then I'm going to do it. I'm going to say the sine inverse of my answer. So you click on the second function, click on the little answer key right here, answer. So it just takes it from the previous answer. Click on that, and voila. Notice I get a negative 21.47. Right. I always teach you guys to always take the opposite value. I just want to show you that here. And so if you do it like this here, so if you got a negative 0.366 as the answer, let's try this here. I'm going to go 0.366. Let's see if that gets us close. Oh, pretty close, yeah. So you have a reference angle of 21 degrees, 21.47. I think we're in degrees. Yeah, we're in degrees. Okay. Alright, so with that, we're going to go quadrant 3 because we're looking for when the sign is negative, and the sign is negative in quadrants 3 and 4. And we are looking at reference angles in both of those. So I have a reference angle of 21.47 degrees. Over here, another reference angle of 21.47 degrees. Alright, so let's take a look at this here. In quadrant 3, in order to get that angle, it's going to be 180 degrees plus your reference angle. And so if I do that, I get myself a 201.47. In quadrant 4, I get 360 degrees minus 21.47. Do that on a calculator real quickly here. I get 338.53. Okay, almost there, almost there. So this is all solved for 4 theta, right? So I have 2 values here. I got 4 theta is equal to this one plus 360k. Remember that little k value still here. But 4 theta is 338.53 plus 360k. So we have not solved for theta yet. But we have a 4 theta on our hands. So let's take a look at this here. You know what? I'm totally running out of space here. So let me write this on the next slide here. So let me rewrite it real quickly here. Okay, I think we're good there. So now we know we have to divide by 4. 4 here, use your calculator here probably to divide all that stuff. So I got theta is equal to, I got 50.4 degrees plus, and that's going to be 90 right over here. Alright, divide by 4 over here everywhere. I got myself 84.6 degrees plus 90 degrees K. Alright, so now the question is, how many iterations of K do I need? I need iterations of K going from 0, 1, 2, and 3. Again, it's always one less than the multiplier to your theta value. Alright, and this one you probably do on your calculator. So just punch it in, use 50 degrees first time, and then just keep on adding multiples of 90. Really, it's going to be 50.4 plus 90 plus another 90 plus another 90. That's kind of there. And then it's going to be now the other side. It's going to be the 84.6. Click on plus 90. Then add 90 again. Then add 90 a third time. And done. Okay. Moving on to the last two problems that we have. So 51, it says that we have a Ferris wheel. Here's the equation for the height of the chairs on the Ferris wheel. This one requires a little bit of sort of thoughtfulness and thinking through things here. So first things first, it says we want to find the time it takes to reach, or when is, at what time is the car in the Ferris wheel at 100 degrees high, or 100 feet high. So h comes in as 100. And let's start solving. So I would subtract 139 first. So that's negative 39. Okay, that makes sense. Alright, next thing I would divide through by negative 125 on this side and this side. Okay, that's going to be a positive. They're not going to reduce, so it's going to be a positive 39 over 125. Now this is all equal to cosine. Okay, what do we do here? We need to undo cosine, so it's going to be cosine inverse of that 39 over 125. And then what we're going to do is we're going to multiply by 10, divide by pi. We're going to do the exact opposites of, or the reciprocal of your multiplier to t. So there's that, and punch that into your calculator and you should get a t value of 3.99. Okay, real quick here on your calculator, just to make sure you are in radian mode. Since we're not in degrees, we're dealing with sort of like real life time values, and time values are never in degrees. So we have that to think about. So the question is, what is this saying? What is it producing? It's about 4. So we say it's about 4 seconds. So let's see if this makes sense. Let's see, I have a Ferris wheel right there. It's about this tall. So from the level ground to the start of the Ferris wheel, you have to walk up those little stairs to get on. It's going to be 14 feet high. And then the Ferris wheel itself has a radius of 125. Sorry, it should be 250 for the whole thing. And so the middle point is going to be 139. So we want to know when a certain cart or a certain car here is going to be 100 feet high. It does say that it takes 20 seconds to complete a rotation. Let me write this in since I'm starting to write anyways here. Rotation. So let's do this. Let's kind of think about this here. If it takes 20 seconds to do a full rotation, so that means it takes 5 seconds for every quadrant. Is that true? So it's going to take, well, let me maybe off to the side right over here. It's going to take, so from the cart to start here to go to here, it's going to take 5 seconds. Then from here to here, it's going to take another 5 seconds. Here to here, another 5 seconds. And back here, and there's your 20 seconds to make a full rotation. So what did we get as far as our answer goes? So in order to get to 100 feet, what we had to do is we had to travel for 4 seconds to get to there. So that means there's one little second missing to get to the middle, to get to the 5 seconds. So we were missing 1 second to get to exactly the middle point. Alright, if that's true, there's your complete 5 seconds for the 1 quadrant rotation. If I keep on going, that means this will be 10 seconds here. This will be 15 seconds here. And then when I go down just 1 more second, I will hit a height of 100 feet again. So how many seconds is that? That's going to be 16 seconds. So answer, I hit, if I just do 1 full rotation, I'm going to hit 100 feet high at 4 seconds and 16 seconds. Alright, last problem here, 6.3, number 53. Alright, we have ourselves a little hexagon. And it says that, let's see, from the middle, I got theta here, my r value for radius, and it's L. So the question is, what n values? And so n values are how many sides do we have to this. So does it work for a triangle? That would be n is equal to 3. N is equal to 4 would be a square. N is equal to 5 would be a pentagon. So the question is this, when is this formula, because that gives you the length, of the side here. So when is the L and the R equal to each other? That's the question. Does it happen when it's a triangle? Does it happen when it's a pentagon, a hexagon, octagon? And so what we do is we're going to plug in, going to substitute the L for the R. And this just becomes a equation to solve. This just becomes 1/2. Alright, and then what we're going to do is we're going to take the inverse of that, and that's going to give us 30 degrees. Let's multiply both sides by 30. I'm sorry, divide both sides by 30, multiply by n, and if we switch those two out, we'll get this right here, and we get n is equal to 6. What in the world does this prove? In order for the radius and the side length to be exactly the same, that is only going to happen when you have 6 sides. So that only happens when you have a hexagon. Alright, that's what we just proved, which I think is pretty cool. Alright, hopefully that was good, and we covered all the homework questions from class in 6.3.